Welcome students to part 6 of the chapter Chemical Bonding and Molecular Structure. Today we are going to see formal charge of atoms in a molecule. So we have seen how to draw Lewis dot structure of a molecule, isn't it? In the last part we have seen how to draw Lewis dot structure of a molecule. Now what we are going to see in that structure of a molecule or a species, how to find out charge of each atoms. So what does this actually mean, formal charge? We will explain this, or I will explain this about this formal charge of atoms when we are using an example. Okay, so let us straight away go there. There is a formula to calculate formal charge of an atom in a molecule. What is that formula? So formula is this: formal charge is equal to, so formal charge of an atom. So Fc means formal charge of an atom, of one atom in a molecule. So there will be a lot of atoms. For each atom, I can use this formula to find out the formal charge. So formal charge of an atom is equal to its valence electrons. So its valence electrons minus inside the molecule how many lone pair electrons does it have. So if it is having 2 lone pair, which means that it has, if it is 2 lone pair, it has 4 lone pair electrons in it, isn't it? So for instance, in a molecule, I will just try to write a molecule, for example, here. So if I am writing oxygen molecule, I have 2 oxygen atoms, I have 2 bonds, that is a double bond, then each oxygen atom is having a lone pair, isn't it? So I am having a lone pair. So how many lone pair of electron does this oxygen have? It has 2 lone pair. So how many lone pair electrons are there? There are 4 lone pair electrons. And what is the number of valence electrons for oxygen? It is 6. So 6 minus 4 minus half of the bond pair electrons. So half of bond pair electrons means it is actually the bond pair, isn't it? So in each bond we have a pair of electrons. So instead of this, I can simply say that half bond pair electrons means it's the bond pair number. So if I have 2 bonds, number of bond pair electrons is 4. In this case, this oxygen has 2 bonds, and therefore the number of bond pair electrons is 4. Half of it is equal to 2, that is number of bonds. So if I am using this formula, I can calculate formal charge of this oxygen. So let us see the same example to calculate. So I have valence electron 6. I am going to write down here. So valence electron is 6 minus lone pair electrons. How many lone pair electrons does it have? Each atom. So I am considering this atom. It has 6 valence electrons. And how many lone pair electrons are there? So it has 2 lone pair, which means that it has 4 electrons. 2 lone pair ആണ് ഈ ആറ്റത്തിനുള്ളത്. If it is 2 lone pair, then it is 4 lone pair electrons. So I am going to write down here, it is 4 lone pair electrons minus, next is what? Next is half bond pair electrons. So for this atom, this oxygen atom, how many bond pair are there in this molecule? There are 2 bond pair. In 2 bond pair there are 4 electrons. So how many bond pair electrons are there in total? There are total of 4 bond pair electrons. Half of it, which means is equal to, so I will write it, which is equal to 2, half of bond pair electron. And what is the sum? Is equal to 0. And same is the case with this oxygen. Its charge is also equal to 0, which means that here, if you are looking into the oxygen, this oxygen, you can clearly see here oxygen is sharing 2 pair of electrons. Half of it belongs to this oxygen itself, and half of it belongs to this oxygen. So if I am taking half of it, that means that oxygen has its electron only, 2 lone pair and half of the bond pair. So he is sharing with it. he has not gained any extra electron. He's just sharing that. So by sharing that, since it is a mutual sharing, you can say it as a gain or it as a loss. So there is a perfect balance. It has lost, at the same time it has gained, so which means that still it has that 2 electrons here. You cannot say that the entire 4 electron belongs to this oxygen because it is being shared by the other oxygen. So which means that if there are 4 electrons here, half of it belongs to this oxygen, half of it belongs to this oxygen. So does this oxygen has gained any electrons? No, it has not gained electron. That's why it is having a charge 0. And at the same time, similar is the case with this oxygen. It has not gained any electrons, so its formal charge is 0. And you will see in the later slides that certain molecules, they have gained electron after that, after molecular formation. Then the charge, we will see what is the charge. Clear? So formula charge is to find, or the formal charge is to find out whether an atom in the process of sharing electron, in the process of molecule formation, has gained electron or lost electron, or is it like this? There is no gain nor loss. Clear? So this is why we are trying to write down the formal charge for the formula of an atom, formula of a molecule. Inside that we are trying to find out the formal charge of an atom. So what is Fc? Fc is formal charge of the atom. V is valence electrons on the atom. So the atom which we are considering, it is the valence electron of that atom. And lone pair of electrons. So inside the molecule, each atom will have lone pair. So it is that lone pair of electrons. And bond pair of electron means in each atom it has bond pair of electrons. It is that number that you have to substitute here. So this is the formula. Using this formula, I can calculate the the formal charge of any molecule. So first basic thing is, in order to calculate the formal charge, I should know Lewis dot structure. So since I knew Lewis dot structure here, I could use the formula of oxygen in order to calculate its formal charge. So basic thing is, you should know what we have learned in the previous 2 parts. How to calculate or how to write Lewis dot structure of a molecule. If you could write Lewis structure of a molecule, you can easily find out formal charge. So how to calculate formal charge? Formal charge is equal to valence electrons minus lone pair of electrons minus half of bond pair electrons. So let's see that. So first we are going to see the formal charge of the atoms of ozone. We know that ozone is quite vital for the life on the Earth's surface, because it is protecting the entire organisms from harmful radiations of sunlight. And this ozone has 3 oxygen atoms. We will study detail about ozone, its properties and preparation in next year's topics. Okay, so for the time being, I'm going to put down or lay down the Lewis dot structure of oxygen. So we have already seen this, so I am directly putting that structure here. Try by yourself in order to write the Lewis dot structure now. So since we have already seen, I am putting it directly in order to save time. So it is like this: oxygen in the center and 2 oxygen on the left and right. Clear? So this is the actual structure of ozone. In the previous part we have seen, we can write it as a straight molecule with O and O on both sides of this oxygen. But in actual life, this is the structure of ozone. Clear? Now there is one double bond, and there is one single bond. Now I am going to find out the formal charge of each oxygen. In order to identify oxygen, I am numbering them as this as 1, this as 2, and this as 3. Now what is the formula for formal charge? In each case, I have to substitute the valence electrons, lone pair electron, and half of the bond pair electron. So I'm calculating first the valence electron in the case of first oxygen. So first oxygen, I have 6 valence electron, we know that. Oxygen എത്ര valence electrons ആണുള്ളത്? It has 6 valence electrons. And how many lone pair is there? You just count it. 1, 2, 3, 4, 5, 6. 6. I substitute that. Then how many bond pair electrons are there? There are 2. Half of 2 will be equal to 1. Which means that it has a charge of -1. So can you identify why it is having a charge, formal charge -1? We know that valence electrons is 6. So you can see the valence electron 6. Apart from this, he is sharing one electron with this oxygen, which means that half of the electron belongs to this oxygen. What does that mean? That means apart from this 6, it has an additional electron for sharing. So how many electrons are there for this oxygen? If I am repeating it again in Malayalam, ഇതിന് 6 വാലൻസ് ഇലക്ട്രോൺ ഉണ്ട്. ഓക്സിജൻ ഓൾറെഡി എത്രയുണ്ട്? 6 വാലൻസ് ഇലക്ട്രോൺ ഉണ്ട്. അത് എവിടെയുണ്ട്? യു ക്യാൻ സീ ദാറ്റ് ഇൻ ദി ലോൺ പെയർ ദർ ആർ 6 വാലൻസ് ഇലക്ട്രോൺസ്. അഡീഷണലി ഒരു ഇലക്ട്രോൺ, ദർ ഇസ് 2 ഇലക്ട്രോൺസ് ഇൻ ദിസ് ബോണ്ട് പെയർ, which means that half belongs to this oxygen and half belongs to this oxygen. Half if it is belong to this oxygen. Now how much is the total number of electrons for it? It is 7, which means that he has an additional -1 charge. സാധാരണ ഓക്സിജൻ അല്ല, അതിനൊരു അഡീഷണൽ -1 ചാർജ് ഉണ്ട്. അതാണ്, that's what it is shown here, that -1. So the formal charge is -1. Now let us look into the second oxygen. In the second oxygen, what happens? We have valence electron again 6, lone pair is 2, and bond pair, it has 3 bond pair, isn't it? So half of 6, that is equal to 3, which is equal to +1. Why it is +1? So you can see oxygen must have 6 electrons, isn't it? So oxygen now have 2 by its own, then it is sharing 3 electrons, its 3 electron with others. So how many this oxygen is having? 1, 2, 3, 4, 5 electrons is owned by oxygen. That means it has lost 1 electron. So can you guess where might have it lost this electron? Yes, this shared electron both comes from this oxygen. This shared electron both comes from this oxygen. That's why we have a feeling that it has +1 charge. But it is actually not +1 charge. What he does is, while sharing, he shared both pair of electrons or both electrons with this oxygen. So now we feel like this oxygen has gained 1 and this oxygen has lost 1. So this is one thing that what will happen if we are using the formula to draw Lewis dot structure. So we have used this formula to draw Lewis dot structure. If you are using that, these things happens, and we will see why it is happening in the coming slides. Not in the coming part, but in the parts that is going to come in this chapter. Clear? Now we are going into the third one, third oxygen. We have 6 valence electrons. Lone pair is equal to 4, lone pair electrons is equal to 4, and we have bond pair electrons is equal to 4. So 6 minus 4 minus 2 will be equal to 0. Clear? So which means this oxygen has not gained or lost any electron. It has 4 electron as a lone pair and it has 2 bond pair, and half of that bond pair belongs to this oxygen. So in total we have 6 electrons for this oxygen, which means that its formal charge is 0. Now you add the formal charges, all the formal charges of all the atoms. -1 + 1 0, which will be equal to sum of this equal to 0. Now what is the charge of the molecule? Charge of the molecule is equal to 0. So that is what we are getting here. So this is the last confirmation to know or to see whether you have done it correct or not. You have found out the formal charge of each atom. ഓരോ ആറ്റത്തിൻ്റെയും ഫോർമൽ ചാർജ് കണ്ടുപിടിച്ചു. You have found formal charge of each atoms. Now you are summing it up. You added all these 3 formal charges and finally you got 0, which means that molecule is neutral. As you can see here, molecule is neutral, and in your calculations you too got it in the same way. Clear? So this is about the formal charge. Now we are moving on to the next example. So formal charge can be written like this. For this oxygen it is -1, for this oxygen is +1, and this is 0. So here +1, what it has lost has a gain for this oxygen. So let us move on to the next example. Formal charge of the atoms in carbonate anion. In carbonate anion. Clear? So we have seen how to write the Lewis dot structure, and I just directly placed it here. For you can maybe pause the video and try to do all those calculations what we did in the previous part in order to draw this Lewis dot structure. So this will be the Lewis dot structure. If you are doing it correctly, you will get it. Now I have 3 oxygen atoms, so I am going to number this oxygen atom specifically. I don't have to number carbon because it's the only atom that is carbon, whereas oxygen, if I have more than one atom, I will number it in order to identify them. Clear? Here you can see 1 and 2 are almost the same. Lone pair and bond pair and valence electrons are all the same, so you don't have to calculate both. Clear? You just have to calculate one once, then you can give that same value to the second one. Third one is different, so you have to calculate this, and also for carbon you have to calculate. So I am starting with the formula. In the case of first oxygen, O1, again I have 6 minus 6 minus, that is half of 2, that is equal to 1, which will be equal to -1. This is like what we saw in ozone, the first oxygen in ozone. Now the second oxygen, the same thing, -1, because both are of same arrangement or same number of electrons, same number of distribution. So both have -1. And what about the third oxygen? Third oxygen is, we have 6 valence, he has 4 lone pair and 2 bond pair, which means that 6 minus 4 minus 2, which will be equal to 0. So the charge of oxygen is 0. And for carbon, you know that its valence is 4, and it does not have any lone pair here surrounding it. It has all as bond pair electrons, so half of 8, all its octet is bond paired, so it is half of 8, then 4 minus 4 is equal to 0. Clear? So what does this formal charge means? In the case of oxygen, it has gained 1 electron. In the case of second oxygen also, it has gained 1 electron. So if you are trying to sum up the number of charges, it will be -2, and you can see that -2 over the species, written over the species. Clear? So this is the formal charge of carbonate anion. This is how to calculate the formal charge. Now next,